You've selected diaphragm. The diaphragm is a musculotendinous structure innervated by the phrenic nerve bilaterally. The phrenic nerve comes from C3, 4, and 5, which keep the diaphragm alive. The muscular structures attach from the costal margin of the ribs, separating the thoracic cavity above from the abdominal cavity below. As it crosses the cartilaginous border between the two structures, it uses the ribs and the costal margin as an anchor point, after which it will have muscular components and more central tendinous portions that will act like a dome during respiration. During respiration, the diaphragm will contract towards the costal margin, dropping the height of the dome and increasing the thoracic cavity space, thereby filling the lungs with air during inspiration. During expiration, the diaphragm relaxes, domes back up superiorly, and compresses the lungs as the ribs contract down like a spring, and that expresses air from the thoracic cavity during exhalation. Now let's take a look at the structures under the diaphragm. Remember, in the thoracic cavity, we talked about three major things that are passing through: the inferior vena cava, the esophagus, and the aorta. As we look deep to the costal margin, we'll be entering into the abdominal cavity, and we'll see the organs of the foregut. On the right side, notice the dome is higher because you can see things like the liver tucked up underneath the right upper quadrant. Here you can see left lobe of the liver and the major right lobe of the liver. There would be two other lobes seen deep to this, which would be the caudate and the quadrate lobe. Separating the liver, we can see the falciform ligament terminating into the round ligament of the liver, which is the obliterated umbilical vein. Then we can see duodenum, which would be circling around underneath, or coming towards the left along the stomach. We can see various components of the stomach, from the antrum to the body, and then tucked underneath the left dome of the diaphragm, here we'd see the fundic structure. When we come around to the posterior aspect, just behind the stomach, we can see here the tail of the pancreas, the splenic artery, and right underneath we can see the spleen tucked up into the upper left quadrant. As we watch the duodenum come in behind with parts 3 and 4 of the duodenum, it's been cut away from the jejunum at this point in this specimen. And that allows us access to see here the aorta with the unpaired vessels of the descending abdominal aorta. You've selected deep back muscles. We'll show you a few of the deep back muscles, dividing them into a superficial and a deeper true or deep back muscle group. These muscles are all innervated by dorsal rami of segmental nerves delivered from the spinal cord. The most superficial of the true or deep back muscles are going to be the erector spinae muscles, which divides into three major groups, all of which, as you can see, putting one side to another side, make the shape of a V because they run up and out. The deeper group, not demonstrated as well on this specimen, is going to be the transversospinalis group, and they run from medial to lateral, down and out, and they would make the shape of an inverted V. The three muscles that we see nicely here are all erector spinae. The more medial of them, seen here, would be running from spinous process to spinous process. This would be the spinalis muscle. Then we can see here the second layer, More lateral is going to be running as the longissimus. And then finally, the most lateral of the three erector spinae is running up and out to attach to the ribs, and that's known as the iliocostalis muscles. You've selected spinal cord. Spinal cord on this specimen is running through the vertebral canal, terminates at the level of the L1, L2 disc, which is typical, and then we begin forming the cauda equina. We've opened up the dural sac, pulled away the arachnoid mater, 2 layers of the meninges, and we can see the spinal nerve rootlets coming together as they head towards the intervertebral foramina at each vertebral level. As we rotate and zoom in, we can see here a dorsal root ganglia supplying the sensory cell bodies of the primary afferent neurons returning to the spinal cord to carry sensation up to the brain and brainstem.